Good evening. We are going to be going over complex numbers, which are your notes for tonight. So let's start with explaining exactly what a complex number is. A complex number is any number in the form a plus bi, where a, I'm going to put that in quotes, is any real number, and bi, I'm going to put that in quotes also, is any imaginary number, like we talked about in the last lesson. So, some examples of imaginary numbers and real numbers put together making complex numbers are negative 3 plus 2i, 0 minus 3i, which would actually just be negative 3i, or 5 plus 2i radical 7. All of those are examples of complex numbers. So we're going to talk about graphing them, which is actually extremely easy. It's pretty much the same thing as graphing a regular number, except for instead of having an x and y value now, you're going to have an a value which goes on the horizontal axis, and you're going to have your bi value which goes on the vertical axis. So your horizontal axis is your a, and your vertical axis is going to be your imaginary number, your bi. A complex number, a plus bi, can be graphed as a point or as a vector. And a vector just means an arrow from the origin to the point. So, looking at this box in the center here, if we wanted to graph these complex numbers, looking at the first one, we have 3 plus 4i. That means you're going to graph 3 as your real number, so you're going to go from the origin, and you're going to go over 1, 2, oops, my apologies, going the wrong direction there. You're going to go over 1, 2, 3, and then you're going to go up 4, because that's your imaginary part. So you're going to go up 1, 2, 3, 4. So your point would be right up here, and we drew a vector or an arrow going to it. Second example, 2 minus 3i would be at positive 2, so you go forward 1, 2, and then you would go negative 3i, so you go down 1, 2, 3, and that's where this arrow here has come from. Negative 4 plus 2i takes us back 1, 2, 3, 4, and up 1, 2 spaces. So our third arrow comes from right here. Positive 3, let me go ahead and erase all this so we can see the next thing. Positive 3 is actually, you can read it on your paper a little better, it's 3 plus 0i. So that means you're going to go forward 3 spaces, and we don't have to go up or down at all, so we actually stay right on the axis there. And our vector is on the line. You can kind of see it on your paper better than you can see it on the video here. And the final one, 4i, is really 0 plus 4i. So you don't go left or right at all, instead you just go up 1, 2, 3, 4 spaces, and our vector ends up going straight up and down here. Okay? So, if I wanted you to graph 3 minus I, that means you want to go forward 1, 2, 3, and then you want to go down 1 on your imaginary axis. So you go down 1 space, and it would end up being right down here. Okay? So we want to go ahead and draw that arrow in, showing exactly where you would. So when you're done, your final answer should be an arrow going from the origin to the point 3, negative 1i, with an arrow drawn on it, like so. There's a bad arrow. Next example down here, we want to find the real numbers a and b that will make the equation true. Some of these are pretty simple, some of them are a little more tricky. This first one though, it should be very, very straightforward. We have a plus bi, we want to figure out what a is and what b is. So just looking at this, you can tell that a matches up with the 3, it's got nothing with it, and b matches up with positive 4. So a and b would be 3 and 4 respectively. This second example down here, part B, we have a plus bi equals 9. Well, referring to that example that we just graphed, that's really 9 plus 0i. So our a in this case would be our 9, and b would end up being 0. Very similar with c down here, we have negative 2i, which ends up being the same thing as 0 minus 2i. Oh, I need to change that color, you can't see that. 0 minus 2i. So our a in this case would be 0, and our b would be negative 2. We are going to go ahead and skip part D and part E. We don't need to worry about those right now. So you can cross them off. Saves you a little bit of writing. And we're going to move right on to example 3. If you want to write something in standard a plus bi form, it means you need to get everything in terms of your constant, just your number, your a, and then your imaginary part, so something with an I at the end. So for this one, we already have our 7, so we can keep that. 7 will be the same, minus, well, the square root of negative 36 is going to be 6i. So this one is actually already written in standard a plus bi form as long as we simplify that square root sign. So 7 minus 6i would be your answer. And I can put my box around it there. Part B is a little tougher. You want to be able to split that 18 up into a perfect square and a not so perfect square. So we're still going to have our 3 out in front, plus, well, 18, we can break that up into the square root of negative 9 and the square root of 2. So as we continue simplifying that, we'll end up with 3 plus, the square root of 9 is 3, the square root of negative 9 would be 3i, square root of 2. And there's nothing else you can do with that. Your imaginary part has the I with it, and in this case it has a square root also, so that will be your answer. That's pretty much all there is with complex numbers for now. We're going to do some operations with them, so adding, subtracting, multiplying, and dividing tomorrow. But for now, you just need to get a grasp on what they are, how to put them in standard form, and what a graph of them looks like. So if you need to look over any part of this again, feel free to. Otherwise, I will see you in class.